In this module, we are going to understand the scientific approach towards the research. When we talk about scientific method, it calls for formation of a question. After a question is formed, then we form certain hypotheses as regards to various aspects of the question. And then in terms of directionality or prediction of the hypothesis, like how A and B are related to each other, A and B could be constructs in our example, like job satisfaction and job performance. And then we go down to test those hypotheses or predictions using various research methods. We analyze the data, and in order to make a valid conclusion, we may also want to increase the number of replications. Take, for instance, if I have a particular medicine and I improve my ability to run in one race, I want to replicate it in n number of races in order to ascertain that the improved performance is not due to chance, but rather due to the medicine itself. And then we communicate it. And there would be external review and also data sharing. So in other words, it follows a step-by-step method. Any of the claims which I make can be verified or not verified based on the results of the various testing procedures. To cite an example of scientific method, let us take the problem why my toaster is not working. I will observe whether the toaster is not working by putting in the slice and putting on the toaster. It's not coming on. Then what could be the question? The question would be, what could be the cause of the toaster not working? I frame a hypothesis based on previous experiences that the toaster is not working because the heating element is broken. In order to test this hypothesis, similarly, I may have other hypotheses too, like there is no power supply coming into the toaster. Now, in this case, I've made a hypothesis that the toaster is not working due to the heating element being broken. I conduct an experiment by replacing the heating element, and the prediction is if the toaster is not working due to heating element being broken, then I changed the heating element, means the toaster should be working now. And I see the result, whether it is positive, whether the toaster works, or negative. And then I conclude based on that my hypothesis was correct or hypothesis was wrong. So in this, the entire emphasis is on testing, forming hypothesis, testing the hypothesis, and making conclusion whether the hypothesis are correct or not. And this makes us to believe that in a cyclical manner, the knowledge progresses. However, when you compare a scientific approach with pseudo and junk sciences, a pseudoscience is a body of ideas or information clothed in the jargon of, if you look at it from an outward perspective, it looks like a scientific piece of work. Take, for instance, astrology, palmistry, and so things. It may initially, you may see that they also talk about planet systems. But when you examine it deeply, you understand by using scientific method, then you understand that it does not hold to the test of the rigorous scientific process. Junk science. Sometimes junk science are used basically to criticize the scientific researches. Take, for instance, people would say that climate change is not real, or people have not landed on the moon. COVID is unreal, and so on, basic through some studies. Or there are examples like smoking causes cancer. Sometimes people who are have vested interest in tobacco company may bring up a junk science saying that these studies are not valid due to ABC reasons. But scientific approach goes in, and whatever the ABCD invalidity, it can go back, test those propositions, and advance. That is the beauty of scientific research. Hence, for discovering knowledge, we use scientific research. There are norms of scientific community. You, being a researcher or a scientist, have to adhere by these norms. First norm is universalism. It shows that regardless of where the research was conducted, who is conducting the research, when it was conducted, and so on, we are not going to be carried away with these particular titles and terminologies. Rather, we are going to judge the research by its merit. We are going to say what hypothesis was formed, how the testing was conducted, and whether the results was concluded based on facts or not on facts. The second rule of scientific communism is organized skepticism. Scientists should not accept any new ideas in a carefree or uncritical manner. In God we trust. Rest all have to bring the data. They should challenge and question all evidence, subject each study to intense scrutiny. The motto here is not to criticize author, but rather criticize the science in order that proper knowledge would be propagated, and studies which are not properly done will not be propagated further. Disinterestedness. Scientists must be neutral, impartial, receptive, and open to unexpected observations, even though it is against their personal beliefs and ideas and so on. So scientists does not have an interestedness, rather he is neutral. They should accept and look for evidence even that runs against their positions, and should honestly accept the findings as it is. Communalism. The scientific knowledge should be shared. It belongs to everybody. Creating a scientific knowledge results in we publishing the research articles, and this can be used by various researchers in order to create new knowledge structures. Honesty. This is a general cultural norm in scientific research. honesty in the procedure, honesty with the data, honesty with who were the participants in it, whether the results are positive or negative, or there is no results. We need to be transparent in all our studies. This brings us end to the module